We've all felt that specific sinking feeling. You're grading a stack of assignments, and you realize the student didn't actually write a word of it. They just pasted your prompt into a text box and let a machine do the thinking. Most students are treating artificial intelligence as a vending machine. They insert the assignment question, wait 3 seconds for the output, skim the first paragraph, and hit submit. It is a single, frictionless transaction. Because of this behavior, traditional assignments like 5-paragraph essays or basic coding tasks are breaking down completely. When the output is generated instantly by an algorithm, a teacher has zero visibility into what a student actually understands. We end up grading the vending machine's inventory, not the student's mind. And trying to ban the tool entirely is a losing battle. The software is embedded into everything we use, and the detection algorithms are notoriously unreliable. The real problem lies in the linear structure of our assignments. We provide students a straight path from prompt to submission, allowing them to bypass the cognitive loop required to actually learn. To fix this, we apply David Kolb's model of experiential learning, a recursive cycle that deepens with each iteration. When a student interacts with AI deliberately, they start with a concrete experience, writing the initial prompt based on their current understanding of the problem. Then, the AI spits back a response, triggering reflective observation. The student has to actually interrogate the output, identifying what landed and what missed. Next comes abstract conceptualization. The student identifies what assumptions they left out and where their own mental model was flawed. Finally, they engage in active experimentation. They intentionally revise the prompt to be more precise, and they try again. In this framework, one rigorous prompt-response exchange constitutes a complete learning cycle. But there is a catch. A circle, by definition, just goes round and round. A student can iterate prompts all day without ever actually gaining deeper insight into the subject itself. This is where Douglas Hofstadter's concept of the strange loop comes in. A strange loop happens when a system moves through a cycle, but arrives back where it started entirely transformed. When a student brings real domain knowledge into that initial prompt, when they provide context and take a firm position, the AI reflects that complexity back. Critiquing that sophisticated output requires deeper thinking, which pulls the cycle upward into a higher level of understanding. The student becomes more capable at prompting because they know more about the subject, and they know more about the subject because the iterative prompting surfaces exactly what they didn't know a moment ago. This ascending spiral represents a structural model for genuine learning with AI, ensuring students climb toward mastery rather than merely circling the same information. Of course, students won't climb that spiral on their own. We have to design our assignments to force them into it. This blueprint illustrates a new pedagogical architecture for AI literacy. It shows how we can move students away from treating these tools as answer engines and instead treat them as objects of critical study. The first requirement is metacognition, represented by the impossible stairs. This pillar forces students to recognize when they are caught in circular, probabilistic traps, pushing them to think critically about their own thinking processes. The second requirement is grounding. Students must take the abstract, mathematically generated text the AI produces and securely anchor it into verifiable real-world meaning and hard data. The third requirement is ethics. This asks students to step outside the system entirely to examine its training data, demanding that they identify built-in biases and structural prejudices. By building assignments around these 3 pillars, we stop asking students to passively consume answers. Instead, we require them to actively study the machine's behavior. For educators, grading the final polished output has become a metric of the past. We have to stop measuring the destination and start measuring the intellectual friction it took to get there. We must evaluate the iterative process itself. In practice, this means requiring strategies like pre-commitment. Before a student is even allowed to open an AI tool, they must explicitly outline their own thoughts, hypotheses, and arguments on the page. Then comes visible justification. Students submit their entire prompt histories alongside their final work, rigorously defending exactly why they accepted, rejected, or revised every single piece of the AI's output. AI has not changed what good learning looks like, but it has forced education to center our assessments on the deliberate, visible, and repeated loop of human thinking.